This is the question asked in today's skillrack daily challenge. So we are given an integer matrix as an input, and every integer in this matrix represents a land. So the government of the city is planning to put roads in this city. So the government needs to buy land in order to put roads. So the government can buy the land only if the integer value is a non-zero. If the integer is 0, then the government can't buy that particular land. So in the first row, the government can buy only this land 2. So the cost of buying the land would be the integer value itself. So suppose if the government buys this land, the cost of buying it would be 2. And if the government buys this land, the cost of buying this land would be 7. So the government plans to connect the first and fourth row in the minimum cost. So our task is to calculate the minimum cost with which the government can link the first and fourth row with roads. And also the government can buy only one land in every row. So the government can't buy more than one land in every row. So now let us solve this problem. So first let us find the cost for connecting the first two rows. So if the government needs to put a road at this position, it can either put road from this 0 or 0. Since both are zeros, the government can't put road at this position. So we neglect it. So it should be made to 0. And then the government, if tries to put road at this position from the first one, so the government can buy the land from these three positions. Since the first two are 0, the government can't buy these two lands. So the government can buy only this land 2. So the cost would be 3 plus 2, 5. And we don't consider this 0 because if we need to connect this land and this land, it is not possible. We can only buy the land 2 and then connect the land 2 and 0. Only then this 5 and 0 would be connected. The 5 and 0 cannot be directly connected. Since it is given that the government can buy only one land in every row, it is not possible to connect this 5 and 0. So we can buy only these 3 lands, and out of these 3 lands only 2 was non-zero. So we bought that land. And now the next, here we can buy only these 3 lands. We cannot buy this land since it is not possible to connect. So out of these 3, 2 lands are 0 and 0. The only land which the government can buy is 2. So 4 plus 2 is 6. So this 4 gets updated to 6. And now this 5. So the government can buy only lands from the first row at this position. Since one is 0 and the another land is 2. So the government can buy only this land. So the cost would be 5 plus 2, 7. And now we should calculate the cost for linking the second and third. So in order to link this 5, the first row it is 0. So the government can't buy this land. And the next it is 5. So 5 plus 5 is 10. And now this land itself is 0. So the government cannot buy this. So we move to the next land. And then 7. So the government can buy either 5, 6 or 7. The minimum out of 5, 6 and 7 is 5. So the government buys 5. And then 7 plus 5 becomes 12. So it becomes 12. And then the last land is 0. So we move to the next. Now we should link the third and fourth row. So if we need to link at this position, then the government needs to buy land from either 10 or 0. Since 0 cannot be possible, the only possible way is 10. So 10 plus 8 would make it 18. And then if the government needs to link at this position, the cost would be, the government can buy either land at 10, 0 or 12. So the minimum out of 10, 0 and 12 is 0. So if it is 0, the government cannot buy it. So the minimum is 10. So when the government buys this land, the government would be able to connect it at 10 plus 1, 11 cost. And then this 2. So if the government needs to link at this position, it can buy these 3 roads. Since 2 are zeros, only one land can be purchased. So 12 plus 2 becomes 14. So 14. And then the last 3. So the government can buy either these 2 lands to link at this position. So 12 plus 3 is 15. The government cannot buy this land 0. So now in the last row we have to find the minimum. So the minimum out of this 18, 11, 14 and 15 is 11. So that is our output. with minimum 11 cost, the government can link these 4 rows. So the minimum cost is 11. Now let us see our sample input. So first let us connect the rows 1 and 2. So if we need to connect at this position 4 from the land 1, then the cost the government can buy either 1 or 2. The minimum is 1, so it would be 5. And then if the government thinks of linking this 3, then the government can buy these 3 lands, and since it is 0, the government cannot buy this, and the minimum cost is 1 and 2. The minimum is 1, so 3 plus 1 is 4. And then if the government plans to link at this position, then the government can buy the lands either 2 or 0, since the government cannot link this 1 and this one. So the possible ways of buying the land are either this 2 or 0, and since 2 cannot be bought, the only possible way is buying 2. So 1 plus 2 will be 3. And then now we shall link the second and third row. So if the government plans to link at this position, the government can buy these 2 lands. So out of these 2 lands, the minimum cost is 4. So 5 plus 4 becomes 9. And then if the government plans linking at this position, then the government can buy any of the lands. So the minimum is 3. So 3 plus 2 is 5. And now this position 1. So if the government plans to link the road at this position 1, then the government can buy either these 2 lands, either 4 or 3. And the minimum out of 4 and 3 is 3. So it is 3 plus 1, 4. Earlier it was 1 here, so 1 plus this 3 becomes 4 at this position. So the minimum value in the last row is 4. So with minimum 4 cost, the government can link the first and last row. So our output is 4. Now let us see how to write a C program for this. So first I am creating an integer n, and in the next line I am accepting the value of integer n, and then I am creating an integer matrix, a 2-dimensional array named mat of size n cross n, and then I am accepting the input matrix. So I am creating a nested for loop, and in every iteration I am accepting the integer and storing it into the 2-dimensional array named mat. So now we have to implement our logic. So again I am creating a nested loop. Here the row starts from 1. So the I loop starts from 1. So the first I loop starts from 1, and then the j loop starts from 0. So we will be iterating through every column starting from the first row. So in every iteration, if matrix of ij is not equal to 0, so if the land is not equal to 0, then we have to find the minimum with which we can buy from the previous above 3 columns. So the above 3 columns would be from j minus 1 till j plus 1. So we have to add the current land value with the above 3 minimum land values, and we have to find the minimum out of those 3. So in order to do that, first I am setting a new integer variable named min and setting its value to a higher value. So it is like 1 lakh, because we need to find the minimum. So we assume the minimum initially to be some higher integer values, and then we create a loop. So this loop iterates from j minus 1 till j plus 1. So we will be traversing through the previous 3 lands, and in every iteration, in order to avoid the out of bound, we check whether the value of k is greater than or equal to 0 and k is less than or equal to n minus 1. So if this condition is satisfied, then the value of k is within the bound, so we don't get any garbage values. So we check it, and then we add the total land values. So the current land value is ij, and then the previous row land value would be I minus 1. So previous row, that is why we use I minus 1, and then the column would be from j minus 1 till j, and it is varying in the variable k. So the column k. So we will add the previous row land cost and the current land cost. So if it is less than minimum, and then it should not be equal to 0. So we check both of these conditions, and if these conditions are satisfied, then we will set the minimum as the sum of the previous and the current land cost. So after the execution of the for loop, we will store the current land cost as the minimum which we have found. So when we do like this, our matrix would have been updated. So finally we have to print the minimum integer present in the last row. So now we have to iterate through our last row. So again I am setting a new integer variable to 1 lakh, and then I am iterating through the last row of the matrix. So I am creating a loop, and then I am considering matrix of n minus 1. So n minus 1 would be the last row, and we will be iterating through all the columns. So if the integer is less than minimum and then the integer is not equal to 0, then the minimum would be our expected output. So we store the minimum, we update the minimum variable, and finally print the integer minimum. So that would be our output. So now I have given the sample input 1 and our expected output is 11. So we also get 11. And now I have given the sample input 2 and our expected output is 4. So we also get 4. So this is the logic behind today's daily challenge. Thank you for watching.